Hello viewers, I am Kausalya. Today we are going to solve problems related with Millman's theorem. So here the problem is calculate the current I in the 4 ohm resistor in the figure using Millman's theorem. So here this is our given circuit. Okay, we need to find the value of current that flows through this 4 ohm resistance. So here just for our reference I have marked the terminals, right? Terminals as A and B here. So let the current flowing through this 4 ohm resistor be I here, right? So here the thing is we are going to redraw this circuit, right? So keep these terminals as such, okay? Keep this 4 ohm as such. So you see at this node what happens? The current gets divided between these two paths, right? So whenever the current gets divided, what does it means? The things are said to be parallelly connected. So here in this case, you see this connection and this connection are parallelly connected to this terminal, right? Just from the diagram, it is clearly evident that they are parallelly connected, right? But just to make it further more clear, when you keep this as reference point, you see this comes in parallel and again this also comes parallel to this 4 ohm resistance, right? So in order to make our calculation simpler, the first step is we are redrawing the circuit. So when you redraw the circuit, you see here we will be having a circuit like this, right? Can you get? This is AB 4 ohm, right? And to this 4 ohm, this is parallelly connected, and again to this 4 ohm, this is parallelly connected. So totally all these three comes in a parallel connection. So here this is our circuit diagram, right? So now we are going to calculate voltage and impedance by using Millman's formula. So here what is the formula is, you see for calculation of voltage, right? Since here we are having two voltage sources, our formula lies like this. V1 Y1 plus V2 Y2 divided by Y1 plus Y2, right? So here in this case V1 is 12 volt and V2 is 20 volt. So we need only Y1, right? So here we are taking reciprocal of these resistor values. So 12 into 1 by 3 plus 20 into 1 by 5 divided by the total impedances are 1 by 3 plus 1 by 5. So here in this case you should never consider the not the load resistance. You should never consider the thing which is asked in the question. Okay, this 4 ohm will finally comes into picture only at the end. So we have to leave this resistance and we have to include the rest of the things, right? So again when you substitute the values, here finally the value of voltage is calculated as 15 volts, right? So now we have find the voltage. Next we have to move with the value of impedance. So again while calculating impedance you should never consider this 4 ohm, right? You have to consider only this 3 and 5. So here the formula is Z is given by 1 by Y1 plus Y2. So here we know the value of Y1, you know the value of Y2, so just substitute it and here the answer is 1.875 ohms here, right? So now when you redraw the circuit, you see this 4 ohm, this remains as such here, and we have find out the voltage and a impedance value, right? So just draw these things, right? And once everything is done, by using the same thing, how to calculate I? I is nothing but V by R, right? Here we are having two values of R. One is 4 and another one is 1.875. So just substitute here. The value of V is 15 and the final answer is 2.553 amps, right? So this is the current that flows through this 4 ohm resistance, right? So here comes the end of this problem. We will move with the next one. Our second problem is use Millman's theorem, find the voltage across the terminals A and B and also the current through the load resistance, right? So here we need to calculate the voltage across this 5 ohm as well as the current that flows through this 5 ohms, right? So here the thing is, the difference between the previous problem and this one is, here we are having an additional resistance of 6 ohms, right? So again here we are having only two voltage sources, therefore our voltage formula, it just remains the same, V1 Y1 plus V2 Y2 divided by Y1 plus Y2. Here V1 is 6, Y1 is 1 by 3, V2 is 20 and Y2 is 1 by 4, right? So just substitute the values here in this formula, right? Once you substitute it here, and by solving, finally here we are ending up with the answer as 12 volts, right? And the next thing is impedance. So again, to find impedance, we have to consider only these two resistors, okay, not this 6, not this 5, because here only the resistors which are connected with voltage sources play a key role. So here just substitute it. So it is 1 divided by 1 by 3 plus 1 by 4, and that gives the answer as 1.714 ohms, right? Again we are doing the same thing, we are just redrawing the circuit. So here this 5 ohm and 6 ohm, they remain as such, and the remaining part we have converted into a single voltage source in series with the resistors, right? So once the circuit is drawn, then the same thing, how to calculate the current here? First we need to calculate the total resistance, right? So when you calculate total resistance, it is obvious, right? These two resistors are connected in parallel and this combination comes in series with this resistor. So here everything is written in a single statement, right? 6 parallel with 5, this combination comes in series with this 1.714. So just substitute the values here. What is the formula for a parallel combination? It is R1 into R2 divided by R1 plus R2. So just substitute it over here, and once you solve, here the final answer is 4.44 ohms. So since we know the value of total resistance, we can calculate the total current, right? It is V by R. So, but what we actually need the current that flows through this 5 ohm resistance, right? So here what is the total current? It is 2.702. So here the total current is 2.702, but we need the current that flows through this 5 ohms. So here we are using the current division formula. So by current division formula, it is given as total current into opposite resistance divided by total resistance. So here the answer is 1.474 amps. So once we know the current that flows through this resistance, we can easily calculate the voltage, right? So it is nothing but I into R. So here the answer is 7.37 volts, right? Here comes the end of this video as well as this problem. If you have any doubt, let me know in the comment section. Thank you.